All right, hello and welcome back. This is part two, continuing the lecture from the evening of September 4th. And since I could just sense in the room that everybody's getting tired and my voice is giving out, and it seemed smarter just to continue it with a quick video for you to look at over the weekend. So hopefully you're enjoying this with a cold, some kind of favorite beverage while you wrap up this final section of chapter two. I am using the same microphone. I'm trying to talk a little louder, and I elevated the volume as high as I could make it and boosted the gain on the microphone itself. So it's all maxed out. This is as loud as it gets. So if you have to turn up your volume, I apologize. I'll keep fine tuning this process. Probably by the end of the semester. So where we left off, if you'll recall, we ended up with encoding application messages, which had to do with encoding things into binary. So going from ASCII at layer 5 into binary at layers 4, 3, and 2. So in the book, it's confusing to me because it starts off talking about encapsulation and message ordering, reliability, semantics, and syntax, and then encoding, and then it goes back to wanting to talk about encapsulation. So at the end of the chapter, it ends up where it starts. So this phrase, vertical communication on the source host, really, this is just encapsulation again. So that's why I had the slide in here kind of warning everybody that we're changing topics yet again. So I'm going back to this picture in the book that I think is really critically important, the idea of an application message getting encapsulated in the layers below it. So in this example, we're using an HTTP message, and it goes down through the stack. And you can't see all my hands waving because I'm just recording audio, not video, but I'm gesturing a lot as I speak to you. So I'll have to work on that, I guess. So step 2, from layer 5 to layer 4, TCP header gets added. Everything goes down. The next one goes down to the internet layer. An IP header gets added. We go down again to layer 2, the data link layer. An Ethernet header gets added. So what I want you to see at this point is right here, assuming you can see my cursor, layer 2 includes all the information from layer 3, layer 4, and layer 5. All the layers above are included in the encapsulation process. Okay, back here. And finally, from layer 2 down to layer 1. So technically speaking, we don't talk about encapsulation from layer 2 to layer 1. It just gets converted to signal. And we say signal because we don't know what kind of signal it's going to be. It might be electromagnetic going across a twisted pair cable. It might be light going across a fiber optic cable. It might be radio signal, radio waves going across a wireless infrastructure. So however the signal gets across the network, that's taken care of at layer 1. But everything above that is encapsulated. And then the final section has to do with standards. So again, kind of a callback to TCP/IP and the whole standards and protocol issue that I started off the class with. So I'm just kind of summarizing some of the big ideas at the end of the chapter here, where does everybody use TCP/IP now? And the answer is yes. Pretty much everybody uses TCP/IP now, which is a great thing. And the LAN technology, not WAN, but the LAN technology that we're looking at layers 1 through 4, it's all pretty standardized. Everybody uses more or less the same thing. It's not like a bunch of people are out there using things besides Ethernet. 25 years ago, some people were using Ethernet, some people were using token ring. That's really gone away now. TCP/IP at layers 3 and 4 is all very standardized. Layer 1 is pretty standardized, as we'll see when we get to that chapter. In terms of who makes the rules, the TCP/IP standards, it's the Internet Engineering Task Force, IETF. This is not an ISO standard, and it's nothing that's enforced. So it's not like the task force is going to come after you and punish you if you've implemented TCP/IP incorrectly or changed the code somehow. They're not going to impose any penalties, any fines on you. Again, it's an open standard. It's up to you whether you adopt it or not. Now, if you go changing the standard in some way, you're the one who's going to pay the penalty because you're not going to be able to communicate with other systems unless you adopt the actual standard. Now, the tricky part is the rules aren't called rules. They're called RFCs. And again, this is just networking terminology. An RFC is a request for comment, which sounds very open, very egalitarian. We're just asking for your comments, which is what happens when a set of rules comes up to the IETF and they're trying to decide whether to adopt it as a new standard, a new version, or an update to a standard. Maybe somebody comes up with a better way of implementing UDP or who knows what. But they come up with a new version. They're going to send it out to their panels of experts to ask for their comments. In fact, they'll open it up to the public for comments. But once it gets approved or ratified, it doesn't change into, it doesn't become a rule or standard or protocol. They keep the term RFC even though it's approved. It's a confusing term, but it's just a networking thing. But it's a term you need to know. So just to kind of end where we began with the 5 layers, this 5-layer model is technically a hybrid model. So we're pulling some pieces from the TCP/IP stack, again, the single most popular protocol in the world, and the 7-layer OSI model. So the 7-layer version is the OSI model. And if you look at layers 1 and 2, those are directly pulled from the 7-layer OSI model, whereas layers 3 and 4 are pulled directly from the TCP/IP model, and layer 5 is kind of a mashup of the TCP/IP model, the OSI model, and some others. And that's where we scrunch down 3 layers in the OSI model, the application, the session, and the presentation layers into one big application layer. It just makes it simpler to understand. So finally, what I would encourage you to do is to ask yourselves these questions. And if you know the answers, then I'd say you're pretty comfortable with the material. If you know the answers without having to look it up. So what layer does a MAC address work at? What layer does an IP address work at? And this is tattoo worthy. I mean, I'm going to beat this into you. What layer does a switch work at versus what layer does a router work at? You've got to understand the difference. It's just fundamental. And then, of course, how many bits are in an IP version 4 address versus an IPv6 address? No, you don't have to know the term undecillion, but you do need to know how many bits are in the address. Okay, you don't need to know how many possible addresses there are. You need to know how long an IPv6 address is. If you can't remember, go back through the slides and refresh your memory, and go back and read the book. I'm talking to you, the person that has not read Chapter 2 yet. You need to go back and read through all of Chapter 2. I'm not kidding. Read it. Now. Stop this video, go back, read it. Okay. And then the last question, what layers for ports, and what is a port? What does a port do? You need to be able to answer questions like that, not just to pass a test, but just to have an intelligent conversation with somebody networking. So if you're looking for a career in networking and security, being a systems administrator, managing any sort of system, servers, and you've got to know the 5 layers, and you've got to know what protocols work at what layers. So it just helps you to understand the vocabulary. And hang on for dear life, because it's just going to get better and faster from here on out through the rest of the semester. So, but this certainly at this point, this lays the groundwork for everything else that we're going to be talking about this semester. So with that, I'm going to stop just to keep this under 10 minutes. And as usual, if you have any questions at all, please come by my office on the 2nd floor of Founders Hall. Call me, send me a text, send me an email. I'll be happy to answer your questions. And yeah, I look forward to seeing you again on Wednesday night. Thanks, and have a great weekend.